Hi everyone, I am Whitroy. Welcome to this audiobook learning video.
Hi everyone, my name is John and I work alongside Whitroy as an electrical tutor.
In this video, we will introduce ASNZS 4836, which covers safe working on or near low voltage and extra low voltage electrical installations and equipment. Before we begin, I want to make something clear about this audiobook. This is not a word-for-word reading of ASNZS 4836-2023. The standard itself must always be read and followed exactly when you are doing electrical work or preparing for the EWRB exam. The official standard is the legal and technical reference. If there is any difference, missing detail, or possible mistake in this audiobook, you must follow the official document. What this audiobook does is take the key ideas from the standard and explain them in simple spoken language, the kind of language you can listen to while driving, working, or revising. It helps you understand what the clauses mean, why the rules exist, and how they apply in real electrical work. So please think of this audiobook as a learning companion, not a replacement for the actual standard. All right, let's get started.
Section 2. Principles of Risk Management. Today we're moving into Section 2 of ASNZS 4836. This section is about risk management. The main idea is simple. Before work starts on or near any electrical installation or electrical equipment, a competent person must decide whether the work can be done safely. Electrical safety is not based on guessing. It is based on identifying hazards, assessing the risks, choosing suitable controls, and checking that those controls are still working. If the risk cannot be controlled enough for the work to be done safely, then the work must not go ahead. Clause 2.1. General. Clause 2.1 explains the basic rule before work starts. Before anyone works on or near an electrical installation or electrical equipment, a competent person must determine whether it is safe to do so. This is done by using a risk management system. All work must be planned and organised to minimise the risk connected with the work. The most effective way to control a risk is to remove the risk completely. In electrical work, this often means de-energising, isolating, securing the isolation, and proving the equipment is de-energised before work begins. If the risk assessment shows that the risks cannot be controlled well enough, then the work must not proceed. That point is very important. The job does not continue just because it is urgent. The job does not continue just because someone is waiting for power to be restored. The job only continues when it can be done safely. This section also explains how to identify and assess risk, how to reduce risk, and how a work permit system may be used. Clause 2.2. Principles. Clause 2.2 explains the main steps of risk management. The first step is to identify the hazards. The second step is to assess and prioritise the risks. The third step is to apply control measures to the risks that have been identified. The fourth step is to monitor and review the process. In simple terms, risk management asks 4 practical questions. What could go wrong? How serious could it be? What are we going to do to control it? And after that, are the controls still suitable? This is the safety thinking that should happen before and during the work. Clause 2.3. Identify the hazards. Clause 2.3 introduces hazard identification. A hazard is anything that has the potential to cause harm. Before work starts, all hazards and environmental conditions must be identified. This includes electrical hazards, but it also includes site hazards, equipment hazards, weather conditions, other workers, moving plant, confined spaces, heat, damp areas, and other things that may affect the job. In simple terms, do not only look at the switchboard or the circuit. Look at the whole work area. Look at the people, the tools, the equipment, the space, the environment, and the way the job will be done. Clause 2.3.1 General. Clause 2.3.1 explains that the first step in risk management is to identify the things that could cause harm. This includes conditions, situations, work practices, and behaviours that could expose people to injury, illness, or disease. It also includes situations where damage may occur to the environment, property, plant, or equipment. Examples include electric shock, arc flash, exposed energized conductors or live conductive parts, cramped conditions, moving equipment such as cranes, hot or wet conditions, and hazardous areas. The major warning in this part is very important. All electrical conductors and parts, including neutral and earthing conductors, must be treated as energized until proven de-energized. Always test before touching. This is one of the strongest safety messages in ASNZS 4836. Do not assume a conductor is safe because it is neutral. Do not assume an earth conductor is safe because it is connected to earth. Do not assume equipment is safe because a switch is off. Prove it before touching. This clause also reminds us that non-electrical energy sources may need to be isolated, controlled, or secured. For example, machinery may have counterweights, hydraulic pressure, pneumatic pressure, springs, stored movement, or other stored energy. Electrical safety often needs to include these non-electrical hazards as well. Clause 2.3.2 Electrical hazards. Clause 2.3.2 explains that electrical hazards within an electrical installation must be identified before work is carried out. Electrical hazards may arise from the work itself and from how the work interacts with the installation. This may include the task being performed, the physical work area, the way the work is designed and managed, the equipment and materials used, the design and condition of the electrical installation, and any modification or design change. It also includes work performed on or near electrical equipment and any defective or inoperable electrical protection. In simple terms, the electrical risk is not only the voltage level. The risk also depends on the task, the condition of the equipment, the protection devices, the work environment, and how the worker could come into contact with live parts. Consultation can help with hazard identification. This may include talking with other workers, equipment suppliers, health and safety representatives, and specialists. The important point is that hazard identification should not be done in isolation when other people have useful knowledge about the equipment, site, or work process. Clause 2.3.3 Electric shock. Clause 2.3.3 explains that possible sources of electric shock must be identified before work starts. Electric shock can come from many sources. It can come from voltage between active conductors, between active and neutral, or between active and earth. It can also come from voltage across open switch contacts, undischarged capacitors, disconnected conductors, static electricity, induced voltage, transformer secondary terminals, different earthing systems, incorrect wiring, faulty equipment, and other sources of supply. Other sources of supply may include illegal connections, UPS systems, motor generators, inverters, solar panels, batteries, and wind generators. Electric shock risk may also come from lightning, the breaking of continuity in an incoming water supply, automatic controls such as float switches, thermostats, time switches, and photoelectric cells, tools penetrating concealed conductors, and electrical welders. The simple message is this: electric shock can appear from places that may not be obvious. A circuit may be supplied from another source. A neutral may become dangerous. A capacitor may still hold charge. A solar system or battery may keep voltage present even when the main supply is off. A control device may energize a circuit automatically. So before work starts, the worker must think beyond the obvious supply switch. Clause 2.3.4 Arc blast and flash injuries. Clause 2.3.4 explains arc blast and arc flash risks. Arc blast and arc flash must be considered in the design, operation, and maintenance of electrical installations. A person working on or near energized conductors or electrical equipment can be seriously injured or killed by arcing faults. Arc flash can produce extreme heat, bright light, pressure, molten metal, flying debris, and a plasma fireball. The heat energy that reaches the worker is called incident energy. Incident energy can cause serious burns. It can also ignite clothing or PPE if the clothing is not suitable for the hazard. PPE means personal protective equipment. This clause also explains that protective devices may not always operate fast enough to protect the worker during an arc fault. That is a key safety point. Do not assume that a circuit breaker or fuse will always protect a person from arc flash injury. The arc fault current may be lower than the voltage short circuit current, and the protective device may not operate quickly enough. For high current equipment, especially equipment rated at 800 amps and above, an arc fault study should be completed as part of the hazard identification and control process. But this does not mean smaller installations are always safe. Other installations may still need arc flash risk assessment depending on the conditions. The practical message is simple. Arc flash is not just a high voltage problem. Low voltage installations can also have serious arc flash risk where fault current is high. Clause 2.3.5 Hazardous areas. Clause 2.3.5 explains hazardous areas. Hazardous areas can create a risk of fire or explosion. These areas may contain flammable gas, vapor, or combustible dust. Live work must not be carried out within hazardous areas. Sources of ignition must be carefully controlled. Ignition sources may include static electricity from clothing, personal items such as watches, lighters, phones, electronic keys, torches, or other battery-operated items that are not suitable for the area. They may also include electrical tools, test instruments, lamps, drills, multimeters, and data devices that are not certified for hazardous area use. Work activities can also create ignition. This includes hot work, welding, brazing, drilling, grinding, impact between metals, impact between steel and concrete, and movement or rubbing of plastics. In simple terms, hazardous areas need special control because even a small spark, hot surface, static discharge, or unsuitable tool may ignite gas, vapor, or dust. Sources of ignition should not be taken into hazardous areas unless the area has been made safe and the correct safe work method is used. Clause 2.3.6 Other risk factors. Clause 2.3.6 explains that other risk factors must also be identified before work starts. These include live conductors, adjacent live conductors, concealed conductors, overhead conductors, underground conductors, cramped working conditions, confined spaces, and multiple sources of supply. Multiple sources may include solar, wind, cogeneration systems, battery banks, UPS systems, inverters, and capacitors. Other risk factors include damp situations, heat, cold, vibration, noise, working at height, falling objects, pressure to restore electricity supply, instability of the work area, conductors or equipment under tension, nearby machinery, below ground work, toxic or corrosive materials, radiation, asbestos, PCB materials, conductive dust, poor work practices, working alone, equipment design, and the position of exposed energized conductors or live conductive parts. This clause reminds us that electrical safety is affected by the whole job situation. For example, a worker may be competent and the circuit may be familiar, but the risk may still be high because the space is cramped, the area is damp, the lighting is poor, another trade is nearby, or the equipment has more than one supply source. Risk management must look at all of these factors. Clause 2.3.7 Work Zone. Clause 2.3.7 explains work zones. If any person is required to work within 3 meters of energized exposed conductors or parts, a competent person must identify suitable risk treatments. In simple terms, when work is within 3 meters of exposed energized parts, the work must be treated as electrically risky and proper controls must be selected. This clause also connects to two important distances. Work near means work within 3 meters of exposed energized conductors or live conductive parts. Work on means work within 500 millimeters of exposed energized conductors or live conductive parts. Inside an enclosed switchboard panel, the 500 millimeter work zone is very important. When the cabinet door is closed, the internal live parts normally do not present the same level of risk because they are contained. But when the cabinet door is open, the worker may be within the work zone and the risk must be controlled. The clause also makes one very important point. Safety must not be compromised because of operational pressure. In simple terms, pressure to finish the job, restore supply, keep production running, or satisfy a customer must not override electrical safety. Information about all hazards and the required control measures must be readily available. Workers need to know what the hazards are, what controls are being used, and what limits apply to the work area. Clause 2.4 Assess and prioritize risk. Clause 2.4 explains the second step of risk management. After hazards have been identified, the risks must be assessed. Before work starts, a risk assessment must be carried out at the work site. The purpose is to assess the level of risk connected with all identified hazards. Where hazards are identified, the risks must be prioritized, and control measures must be put in place. In simple terms, not all hazards have the same level of risk. Some hazards may be low risk, some may be high risk, some may be life-threatening. Risk assessment helps decide which hazards need stronger controls and which controls must be applied before the work can continue. The risk assessment should consider both likelihood and consequence. How likely is the harm? And if it happens, how serious could it be? Clause 2.5. General Risk Control Measures. Clause 2.5 explains the third step of risk management. After identifying the hazards and assessing the risks, control measures must be applied. This clause introduces the hierarchy of control. The hierarchy of control is a step-by-step system for reducing risk. It starts with the most effective control and moves down to the least effective control. The most effective control is elimination. For electrical work, this often means switching off, isolating, and proving the equipment is de-energized. If elimination cannot be achieved, then the next options are considered. Substitution may be used, such as using battery-powered tools instead of mains-powered tools. Separation or isolation may be used, such as barriers, distance, or physical separation from the hazard. Engineering controls may be used, such as design changes, automation, local isolation, containment, limitation, or residual current devices. Residual current devices, or RCDs, can reduce certain shock risks by disconnecting supply when an earth leakage fault is detected. Administrative controls may be used, such as workplace policies, procedures, SWMS documents, safe work practices, warning signs, and training. A Safe Work Method Statement, or SWMS, is a written plan that sets out the work steps, hazards, and control measures for higher risk work. PPE is the final level in the hierarchy. PPE means personal protective equipment. It may include protective clothing, gloves, face protection, eye protection, hearing protection, footwear, respiratory protection, and other protective items. But PPE should not be treated as the first line of defense. It is the least preferred control when used by itself. The simple message is this: do not start with PPE and ignore better controls. First, try to remove the hazard. If that cannot be done, reduce the risk using the strongest practicable controls. Then use PPE for the remaining risk. This clause also reminds us that more than one control may be needed. For serious hazards, a combination of controls is normal. For example, a job may require isolation, barriers, a safety observer, insulated tools, a permit, and PPE. The controls may also need to change depending on the task, the work location, the duration of the work, fatigue, and exposure. Clause 2.6. Monitor and review. Clause 2.6 explains that risk management does not stop once the job starts. The risk management process must include ongoing monitoring and periodic review. Monitoring and review should happen at all stages of the process. Responsibilities should be clearly defined and actions should be recorded. In simple terms, conditions can change during the job. A cover may be removed. Another worker may enter the area. A different supply may be discovered. Weather may change. The job may take longer than expected. Fatigue may increase. The work method may change. When something changes, the risk assessment and control measures must be reviewed. The worker should not continue as if nothing has changed. Stop, reassess, and update the controls where needed. Clause 2.7. Means of reducing risk. Clause 2.7 explains practical ways to reduce electrical risk. Electrical safety should be maximized wherever possible when working with electrical installations or equipment. Electrical safety depends on good job planning by a competent person. It also depends on correct isolation and testing procedures, suitable safety equipment and tools, suitable test instruments, suitable PPE, competent workers, warning notices, and barriers that prevent accidental contact with energized parts. Again, the key warning appears. All electrical conductors and parts, including neutral and earthing conductors, must be treated as energized until proven de-energized. Always test before touching. This is not just a sentence to remember, it is a work habit. Plan before touching. Isolate before touching. Test before touching. Prove before touching. Work should also be planned in advance where other services may be present or affected. This may include gas, telephone, data communications, water pipes, other electrical circuits, other energy sources, and other trades working nearby. Work should also be planned so it does not put essential equipment at risk. For example, emergency lighting, life-preserving equipment, or medical equipment such as dialysis machines may depend on electrical supply. In simple terms, risk reduction includes more than protecting the person doing the job. It also includes protecting other people, essential services, and equipment that may be affected by the work. Clause 2.8 Work Permit System. Clause 2.8 explains work permit systems. Some electrical installations may use a work permit system to control access to work carried out on or near electrical installations or equipment. A work permit system is used where there is potential for injury or equipment damage. The permit system may set conditions for accessing electrical equipment, using electrical or mechanical isolation, using safety observers, using safety equipment, restoring operational status, and other relevant matters. In simple terms, a permit system controls who can do the work, what must be done before work starts, what conditions apply during the work, and what must happen before equipment is returned to service. A work permit system may require additional practices beyond ASNZS 4836. So if a site has a permit system, the worker must follow both the standard and the site permit requirements. That brings us to the end of Section 2 of ASNZS 4836. This section gives the foundation for safe decision-making before electrical work begins. The strongest message is simple. Identify the hazards, assess the risks, control the risks, monitor the work, review the controls when conditions change, and, if the risk cannot be controlled well enough, the work must not go ahead.